Three designers sit around a table in a meeting room at an automotive OEM discussing the design of their interior user interface for their new car. The design concept is to integrate the center console with several hardware buttons, the cluster with two round instruments and a small portrait display between them, the heads-up display, and the steering wheel with its input controls. Our designers have a great concept, but they are frustrated that they do not have an effective way to capture and express their ideas. They really want a way to create and demonstrate their new ways of interacting with their vehicle. They have established standalone concept, but they do not know how well they will integrate into one great user experience. This effort has become really complicated. They scratch their heads for a solution. John remembers hearing a conversation about NNG's next big thing. He sits at his computer and opens his favorite web browser, navigating to nbt.nng.com. John watches a few videos and learns more about how NBT Studio can revolutionize his development process of automotive UI/UX. John opens NBT Studio, creates a new project, and invites his team members to join the project. The other designers and developers receive a small pop-up notification of their incoming emails welcoming them in the new project, codenamed Something. Time to have some fun! The new project starts with a blank workspace. John drops in the rendering of the vehicle interior as a background image. John models the overall vehicle system by dragging and dropping pre-configured components that describe the physical hardware of the vehicle. Components like a touchscreen to the middle of the console, several hardware controls beneath it, two indicators to the cluster and a non-touch display in between them. He then adjusts the size and orientation of the cluster display. He also adds steering wheel controls and a heads-up display to the stage. Once the controls are placed, John can customize the parameters of each to match the intended vehicle hardware. For the touchscreen, John defines a capacitive technology with multi-touch gestures. He also sets the resolution, dots per inch, and color depth. For the hard controls, he defines the types of controls, their parameters, and intended purpose. John then associates the touchscreen and simulated hardware controls by grouping them into an interaction surface. He is then prompted to name this interaction surface. He names it Head Unit. He does the same thing with the right side buttons on the steering wheel and the center display of the cluster. He names this Cluster. Again with the left side steering wheel buttons and the heads-up display, and then names this Heads-Up Display. NBT Studio automatically populates the interaction surface drop-down menu. Next, he opens the module library in NBT Studio. This library lists all available modules that can be added to the project. From this list, John selects navigation, FM radio, internet radio, media player, HVAC, and car controls. The selected components are loaded into the project module bar on NBT Studio's main screen. As John continues adding modules, graphic designers James and Mary open their NBT Studio and create several style guides into its style library. They each create their style guide by importing artwork from Photoshop, Illustrator, and other tools they use. James is working on a more sporty look and feel for buttons and gauges, while Mary is creating a luxury version. The style guides created by James and Mary are automatically available to all project team members. With all the modules in place, John starts creating the user experience of the new vehicle. He associates the different feature modules with each of the interaction surfaces. This automatically brings in the default workflow and layout. When he drags the HVAC to the head unit, this applies the default touchscreen workflow, layout, and it also automatically assigns the appropriate HVAC functions to the head unit simulated hardware controls. This default layout is pretty good, but doesn't fit their design concept. John edits the layout and applies James' sporty style guide to get his first look at their new concept in action. He then switches to Mary's style guide to verify that design too. As John quickly adds the media player and navigation to the head unit, he also drops navigation to the cluster. As a result, the cluster display starts showing next turn information, but not much more. This is defined by the rules for navigation information on a small, non-touchscreen display. With these additional features added to the head unit interaction surface, their workflows are added to the Workflow Manager. John can then link the workflows with custom menus and features. John has defined the system's default workflow just by dropping module components and linking them together. While editing the cluster, John opens Vehicle Bus Module, selects current speed and tachometer values, and drops them on the indicators on the left and right side of the cluster. The indicators will now function as speedometer and tachometer. Before applying the style, these were simply numerical indicators. With James' style guide selected, the indicators now appear as two sporty gauges. With Mary's style guide applied, they appear as linear bars. John then opens the heads-up display interaction surface, selects Vehicle Bus Module, and drops in current speed, then selects the navigation module and drops the next maneuver icon to the HUD. Something is not right. The next maneuver icon on the HUD shows a red exclamation mark. John hovers over the warning sign and a pop-up says, "Warning, missing style guide element." John clicks the pop-up and sees a to-do work item has been assigned to James and Mary. James and Mary also get a notification on their desktops, and by opening it, they can see the new task in their task list. Once they complete the task, the warning message is removed from the HUD on John's desktop. John creates a new screen state in the head unit workflow called Rear View Camera. He drops the Rear View Camera item from the Vehicle Bus Module into the state. The image is automatically configured as a full-screen image. John wants the Rear View Camera image to be displayed when the car is in reverse. John creates a to-do item for Robert, the developer, to write this script. Robert gets the notification. He selects the Handle an Event option and uses the visual scripting tool in MBT to write this script. Since it is such a simple script, there is no reason to use an external code editor. Having the basics now defined, our designers can start working out the details. They review all the screens and change the automatic layout to fit their needs. They continue changing the workflow, adding new screens as needed, define screen transitions and control animations. NBT Studio warns them whenever it sees inconsistencies, misplaced screen controls, unreadable text sizes, unimplemented functions, missing graphical elements, etc. John uses NBT Studio's export function to create printed workflows, layouts, design review documents, even PowerPoint presentations, scripted and non-scripted simulations, and a guided video tour. A few weeks later, they feel the concept is ready for demonstration to upper management. While they can always use NBT Studio on a PC to simulate modules, vehicle controls, and interaction surfaces, a real-world demonstration always feels better. They create a vehicle buck and gather together in a meeting room with their management team. John uses a computer monitor as the center console, and tablets to simulate the car's heads-up display and cluster. They also include off-the-shelf hardware controls for knobs and buttons. With each device logged into NBT Studio, John can assign the interaction surface to each device and the hardware controls. It is easy to set up an environment like this. Some of the modules are simulated on John's notebook, but the radio module, for example, is a real pre-production piece of hardware connected to the network and controlled by NBT Studio. The big boss is happy. He has one simple request: to change the shape of the gauge pointer. No problem. Linda creates a new artwork, updates the project, and a few minutes later, with the press of a button, the gauge pointer changes. For the past few weeks, Susan and her team have been busy with integrating the NBT engine to the concept car's central infotainment hardware. Now they feel ready for some tests. They log into the NBT project, select the Export HMI function to generate the final asset package for the car, and save it to a USB stick. Then, they put the USB stick into the concept car's infotainment console and load the HMI. They are ready for testing. With the built-in test and report function of the NBT engine, they can report issues into the NBT project right on the spot. The system automatically collects relevant log files and information and attaches it to the issue. The car, having connected to the wireless network, can also update the car's software with the press of a button. A few months after, the whole team, smiling, sits in the just-released new car, enjoying the result of their work, and drive into the sunset.